My name is Balázs Bucsay, and I'm going to present you the XFLTReaT building a tunnel. But before I start, a few words about me. I'm a Hungarian hacker. Some of you already know me, probably. I moved to the UK 2 years ago, and since then I'm working for NCC Group. In the last 2 years I was promoted twice. Now I'm a managing security consultant. I do all kind of offensive work and some defense as well, but not much. I only have strictly technical certificates listed on the slide, and I started to do these kind of stuffs in 2000. So, 2000, when I was 13 years old. I had a few presentations here, and this is a jubilee for Hacktivity, but a jubilee for me as well, because I had my very first presentation in Hacktivity. So I can thank a lot to this conference, and you, of course. I had a few major projects in the past, like G.I. Joe. I presented that in 2009 here on Hacktivity. Then XFLTReaT a few years ago, 3 years ago, again here. And now I'm doing this exfiltration research, XFLTReaT, that I'm going to present. If you like my presentation or the tool, please follow me on Twitter. My Twitter handle is XOR-EIP. And my LinkedIn profile is there as well on the bottom, so you can find me easily. I was quite lucky with this research. I managed to travel around the world. I went to Hawaii, to the ShakaCon, RoxCon to Australia, Singapore to Hacking in the Box GSAC, and a few other conferences around Europe, in London, DeepSec in Vienna, and BruCon in BruCon and Ghent, Belgium, and of course now I'm here. The topic is always changing a little bit, so you will get some new content as well. The presentation and the tool is called XFLTReaT, but it's not really about exfiltration. You can use the tool for exfiltration, but the main purpose is to building tunnels. So this is how it looks like when you connect to the internet. On the left-hand side, you have your computer, which is connected to a modem or a router, and that is connected to the internet, really. And you have two different servers. At this time, you are going to use the bottom one on the right, which has all your cat videos, because you really like those kind of stuff. And whenever you want to watch those videos, you need to connect to the server. And when you do that, you go through your modem or your gateway through different routers, through different hops on the internet. But whenever you are using a VPN or a tunnel, your route will be a little bit different. You have your other server where you installed your OpenVPN service or Cisco AnyConnect VPN server, whatever. So you connect to that server first, and then whatever you send, it will go through that route, and at the end, it will be redirected to the original server. So the original server, which stores your cat videos, will only see not your IP address, but the VPN server's IP address. So this is basically tunneling. This is how the VPN works in usual cases. Why would you use a VPN or a tunnel? Maybe because you want to hide your IP address, because you are a journalist who wants to stay anonymous, or you do BitTorrenting, or you just want to use VPNs because you want to access the internal resources of your company. So like you want to print or to access file shares and so on. But of course there are different reasons. For example, you want to bypass CAFT portals, or you want to bypass corporate proxy policies. That can be done. Unfortunately, we don't have too much time, so I will kind of skip this. But if you wanted to use TCP for tunneling, you had to use OpenVPN or Cisco AnyConnect. If you wanted to use UDP, again OpenVPN. For HTTP Connect supporting proxies, there is a support. There is support for in OpenVPN, or you could use Proxyfire for ICMP, hence ICMP TX or Ping Tunnel. These are one of the many. And for DNS, there is one obvious one, which is a pretty good choice, which is iodine. That's really good. So a little bit different topic. When I went to Africa, from Italy. It took 2 days, and I was in a ferry, and I had no access to the internet because I was cheap, and there was no signal on my phone, but there was an open Wi-Fi on the ferry. So I started to poke around, and I realized I either pay very expensive money to get some internet, or I do something else. And I figured out that the port 443, which is usually HTTPS, was unfiltered. So if I have set up an OpenVPN service on my server, beforehand I could have used the internet for free for 2 days and I don't get bored. But I didn't do that because I forgot to set up. I didn't know in advance. Then next time I was flying to Japan, and on the airplane there was Wi-Fi again, and I figured out the ICMP, so pinging hosts on the internet was working. So I could have used the internet for free if I have set up my tool, but I didn't do that, so shame on me. And this is coming back to me every time when I go to an airport. The DNS tunneling works. Not on Heathrow though. So that whenever I connected to my DNS tunnel, it crashed, so it didn't work. What did I see at the end? So as many protocols, as many things that you have, that many solutions you have on the internet, or there is no solution for it. The tools that there are out are unsupported, end of life, or proof of concepts only. So if you have a problem, nobody will care about it. It won't be fixed. The configuration is always different, so you need to learn all the tools, how to configure it, how to set up, and you need to set up different tools on the same box if you want to use these in the same time. No modularity, portability issues, and of course, the implementations are using really different languages like Perl, Ruby, Python, C, Java, whatever. So you can't know everything, right? So it was really hard to do tunneling before, but I think I managed to change that, but I really like to think that. So that's why I created XFLTReaT, which is a tunneling framework, so that this is how the beast was born. So before I go into the details, you need to understand what's tunneling really. So basically, let's say you have a network where everything is filtered, except one thing, which is ICMP, so you can ping stuff on the internet because that's unfiltered, but any other stuff like TCP, UDP will be filtered by the firewall. So what you can do, you can basically set up an ICMP tunnel on the server, on the client, and you can capture all the packets on the client side and encapsulate it into an ICMP, into a ping packet. So on the green one, on the top left-hand side, that's the original packet. You grab that, you encapsulate it in the other kind of packet, which is unfiltered on the network. You transmit over to the server, which will decapsulate it and get the same original packet that you wanted to send, and it will forward it to the destination that you wanted. And whenever you do the same in backwards, that's how you communicate back and forth. So what's XFLTReaT? We know what's tunneling, so this is a tunneling framework. It's open source, it's Python 2.7 based, object-oriented, modular, multi-client, and there is a check functionality as well. I'm going to tell you about these. So it's pretty easy to use, I believe. The feedbacks are not showing that in every time, but I'm working on that, or it would be nice to have your feedback as well. So basically, you need to go on GitHub or clone it, install the requirements with pip. It's really basic. Edit the configuration and run it. That's it. You do the same on the server side, and you have a tunnel. That would be the theory in behind. All the transportation, encryption, and authentication stuff are modular. So whenever there is a new release, you just copy the files into the corresponding directory, and that's it. You edit the configuration again and run it. So why is it a framework? Please raise your hand if you have ever tried to do tunneling, you created your own tool or whatever. Okay, some people. So you know that it's a pain, because if you want to do tunneling, you should be able to do only one thing, to know how to put your packets into another kind of packet and how you get your data from that packet. But that wasn't the case. You had to set up the interfaces, IP address on that interface, routing as well. If you wanted to handle multiple clients, then you had to code that. Then there is encryption, authentication, you might need that. So if you created your own tunnel, you had to take care about these, which are really annoying. But now, because it's a framework, you don't have to do that. It's all taken care of by the framework. You only have to do two things. One, really, figure out how you put your data into the pocket. So how you encapsulate your data and how you decapsulate your data from that pocket. That's the only really thing that you need to know when you are developing for the framework. And of course, if you are implementing a new kind of protocol, then you need to implement the protocol-related things, but nothing else. The check functionality is really handy when you connect to a new network, and you need to figure out what kind of protocols, what kind of stuff you can use to break out from that network. You have your server set up, configured on the internet, and on the network where you connected and you don't know that network, you just execute the check functionality. And with all the enabled functions, it will generate a packet with the challenge. It will send it to the server. And if the server answers, then you know that you can communicate with the server over that channel. So this challenge is not cryptographically secure, nothing like that. It's just it's just a functional stuff. So it's like sending two numbers, and the server needs to sum up and send it back. And when you know the sum that you got back is the same as you calculated, you know there is an XFLTReaT server, you can communicate with the server because it answered, and so on. This is the multi-operating system support matrix. As you can see, NetBSD, FreeBSD, OpenBSD is not supported at the moment. Probably it should be really easily supported because you just need to change a few things about routing and interfaces, but that's nothing special. All the other modules should work like instantly. Linux is the main operating system that we support. As you can see, almost everything is supported on Linux. And the Windows support was introduced a half year ago. And the best thing about that, there is RDP that I'm going to show you and tell you about. The DNS is proof of concept because of different reasons. I don't really have time to finish at the moment. It's quite hard to do tunneling over DNS. It's quite hard to do reliable and fast tunneling over DNS. So that's the thing. Ease of development. Because it's object-oriented, every module inherits its parents module, methods, and variables. There is a generic module on the top. It has all the methods and properties that are used all over the other modules, right? And there is a split, stateful and stateless modules. The stateful, like TCP, HTTP, those are stateful protocols. So you have a full dedicated connection, a session between the two sides that you can so if there is a packet, you know that basically related to that session. When we are talking about stateless protocols, UDP, ICMP, it's really hard to tell. It can be done, but there is a split. That's how I implemented it. And for example, if you want to do HTTP connect, if you want to create your own HTTP connect module, you just inherit all the stuff from the TCP module, so you don't need to care about many things. But because we are talking about HTTP connect, you need to craft a HTTP request and the response, and from that point, everything is handled by the TCP module. So that's quite easy to do. It's like half an hour work. But it's already done, so you don't have to do it, but maybe with something else. Whenever you connect to a VPN, or not whenever, but most of the cases, it creates a full tunnel. So everything that you are sending out of your network will be tunneled into that channel and will be sent to the internet over that channel. But whenever you are doing split tunneling, you can specify, for example, with this tool, you can specify in the scope.txt file what kind of IPs and IP ranges should be treated as split tunnels. So everything that you are sending to those IPs will be sent over the network or over the tunnel, but nothing else. That comes really handy when you do penetration testing. I'm going to show you why. So the Windows support in XFLTReaT was introduced like half a year ago. If you want to use it on Windows, you need to install the OpenVPN tab driver, because there is no tab driver at all in Windows by default. Obviously, you need to install Python 2.7, the requirements like py-win32, which is needed to access the APIs of the Windows subsystem. And if you want to do a Windows server from XFLTReaT, you need to set up the routing net, and you need to start that service. If you want to uninstall it, you just do it backwards, so it's really easy. A little bit different topic here, remote desktop dynamic virtual channels. So whenever you connect to a whenever you connect to a remote desktop or terminal services service, so basically you use that on Windows, right? You can do copy pasting, right? And when you connect from the client to the server, you copy a file between the client and the server. There is a virtual channel created in the RDP session, and that is used to transfer the file. So it's not doing any new connection besides the RDP connection that you already have. It's basically using that connection to send data in that. So it's really handy because from 2008, Server 2008 and Vista SP1, this functionality was published, the API was published to developers. So you can create your own modules, you can create your own DLL, and with that you can create your own dynamic virtual channels between the two sides, between the client side and the server side. So that can be used for many things, for example, tunneling as well. For that reason, not part of the XFLTReaT, but as a different project, I created this tool, which is a universal dynamic virtual channel connector, which is a bit mouthful. But anyways, you can find it on GitHub. It's really useful for malware writers, for example, or for those who want to do penetration testing or tunneling. It has two parts. There is one DLL that you need to register on your client computer, on your computer in Windows, and then you can set it, you can change the settings from registry. I'm going to show you that. After that, when you connect to the server, there will be a pop-up like that, which will tell you this is enabled and you need to care about those things. On the server, you need to copy an XC, and the XC has three different, and with the XC, you can make this connection over the RDP session. This tool supports three modes on both sides: listen, connect, and name pipes. You will going to see what are those. So this is basically a use case for this. And just to understand what I'm talking about, when you are using OpenSSH or SSH, you can do port forwarding when you connect to a server. That functionality was missing from the RDP, it's still missing, but with these dynamic virtual channels, you can do the same functionality. So you can open up a channel inside SSH or RDP, and you can do port forward or send any kind of data. On this slide, let's say you have a PCI zone. PCI zone always needs to be segregated from the network, and there should be only one access point where you can log in. So usually in big companies, that access point, that one point is the jump box. Jump box is usually either a Windows or Linux box, right? If it's Windows, the remote desktop is used, and usually it's fully firewalled, so there is only one port that is accessible, and that's the RDP, the remote desktop port, which is 3389. So you can't really connect out, you can't really connect to any other ports because it's firewalled. And on the right-hand side, we have three segregated servers, let's say in the PCI zone, and we figured out on the first one, on segregated one, there is a web server which is listening on port 80, right? So on the DLL, on the client side, we set up the configuration as, we set it up in listen mode, so it will listen on all interfaces on the elite port, as you can see on the left-hand side. And on the right-hand side, we set the XC, we execute the XC in connect mode, and it will connect to the segregated one computer port 80. And whenever you open up your browser on your client computer and type localhost elite port, all the data will be forwarded to the segregated one over the jump box, over RDP, and the data will be coming back on the same route backwards. So that's how it works. There is another mode. Actually, there is another use case that you can use. For example, on the segregated toolbox, you found a passwords.xls file. So you want to exfiltrate that, you want to grab that file, but you can't really do that any other ways, just if you are using this tool, for example. So you set up both sides in listen mode. You go to your hacking box on the left-hand side, you connect to the client box, and you wait for the content of the file that will be written into password.xls on your computer. On the right-hand side, after that, you connect to the server. You connect to the jump box from the segregated server, and you put all the file content into that socket. So it will be sent over TCP from the segregated toolbox to the jump box, then from there over RDP through the dynamic virtual channel to the RDP client, and again TCP between the RDP client and the hacking box. So that's how you can get fries. And there is a third use case where you can use namepipe. That's more like for fun. So please raise your hand if you have ever encountered these problems. For example, have you ever struggled testing over a jump box? Only one, two, a few. Okay. The other question: have you ever been in a situation where you had to provide a list of tools that you need to install on that jump box? Again, a few people. Yeah, that's an issue. And have you ever had this problem when you were on site or whenever, and you install those tools on the computer, on the jump box, but you realize later, a day later, that you didn't get approval for a third tool or a 100th tool that you will need for the testing? So that's again a common issue if you're doing penetration testing in a PCI zone, for example, because getting approval is not like 5 minutes, it's probably a few days. So you waste a lot of time. But if you are using XFLTReaT, as I already explained to you, you only need to set up and install a few things, a handful of things on the jump box. So you will never ever forget about anything, because you can use your Kali box, your Nessus, and you can just tunnel everything over the tunnel. So that's why I created the RDP module, which is Windows only and server only. So you need to run it on the jump box after you installed it, and because it's layer 3, it's tun, not tap. That's why it's knotted. It's a restriction, but it's still really good. I already tested a few clients over this, and it went very well. So the demo part. After you install the XFLTReaT, there is the configuration file. It should be really easy to understand, but it seems that some people are struggling with it. So we have three boxes here. There is one Kali box, that probably you know that. There is this Windows box, which will be the client. This will be the jump box. So I will use this to connect to the segregated network. And there is a third one, which I'm going to show you. So it has only one interface. This is the IP. I hope you can see that. And this is the client where we can access the network that I'm using to run Kali. So I can access that IP, but I won't be able to access the other network from the Kali, but from here. So if I ping this IP, then it answers. But if I go to the Kali box and I ping that IP, destination host is unreachable. So that's not going to work from that. But we want to use the Kali for testing because we have all the tools there, right? So this is the configuration. You need to set the IP address of the XFLTReaT server. This will be that. You don't really need to change anything about the server part or the client part. That's not going to be used right now. If you want to do split tunneling, you need to specify the IPs in the scope.txt. There is authentication. This is the key right now for this presentation. The encryption is turned off because that's local network, and that has a performance impact. Not really huge, but we are not going to use that right now. And we are going to use TCP generic, so it's enabled. The port is this port, the elite port, and all the other modules are turned off, so enabled no, ICMP enabled, no SOCs, no, and so on. So we don't have to care about that thing. This is again the client. So we can access the segregated network from this client. And this is the registry, which is hard to see, but there's this enabled stuff. So whenever you execute MSDSC, the remote desktop connection client, then that DLL that I was talking about will be registered and will be loaded into the context of this process. From registry, you can enable it or disable it. You can set the mode to listen, connect, or name pipe, and you can specify the port, name pipe, and so on. Everything is set. When you connect to the server, it will listen on all interfaces on port elite. I'm sorry, that's a bit small. It's hard to see. So we connect to the segregated network to that host we are in. As you can see, it's remote desktop, the same box. We have the XFLTReaT server here. There is the configuration for the server as well, so we are going to run it. As you can see, I hope you can, it started the module RDP and connected to the virtual channel, which is universal DVC. That's the name of the channel. And if you go to the client and you look for that port that I was looking for before, you can see it's listening on the elite port on all interfaces. So we don't need that box anymore. And let's try to ping again. It's not working because we are not connected to that. But if we are using the XFLTReaT client to connect to the client Windows box where we use the remote desktop connection, then it should work. Of course, it's not. The IP is always changing in VirtualBox, so I need to change the configuration because the IP was different when I got on the stage. Okay, so the authentication was successful, so we should be able to ping that host. As you can see, now we are able to ping that host. So that means that the XFLTReaT client connected to the terminal, to the remote desktop server client, and from that everything is tunneled over to the XFLTReaT server on the segregated network. So we can access anything in the segregated network if we issue an Nmap Scan. That should work. It's pretty slow. It's not the fastest because it's knotted. That's the only limitation here, so you need to be careful not to fill up the knot table, but it's really nicely working. As you can see, port 2880 blah 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 is open on the server, and that's going through the XFLTReaT tunnel into the segregated network. So basically, you can use any kind of tool from your Kali box right now because everything is tunneled to that network. You can use Nessus as well. You just need to make sure that everything is routed through that tunnel where you set it up. Thank you. I think it's hard to understand and hard to explain as well, but it works really good in practice and it helps the pen testers a lot. So about the offense, it was mostly written for offense. You can use it for different things. If you want to exfiltrate data, it's a good choice, maybe not the best. Then you can bypass corporate proxy policies. You can bypass CAFT portals and on the airport. You can do like penetration testing over the tunnel and get access to segregated networks as well, and so on. So about the exfiltration, because this is based on an IP tunnel, full IP tunnel, so every IP header, TCP, UDP header, and everything will be transmitted over the protocol that you are using for the tunneling, it will be a little bit noisy. So, for example, if you want to exfiltrate data over DNS, then the DNS packets will be bigger than expected because you have a big overhead, basically. But it can be done, and it works really well. But maybe if you want to do exfiltration and you want to be under the radar, then maybe it's not the best tool for you because it's, like I said, it's quite noisy. The tool was already released. There are 2 URLs that I can tell you. The first one is the XFLTReaT.info. It's kind of hard to remember, but it's just a placeholder. It will redirect you to the second one, which is the GitHub repository for XFLTReaT. If you like it, please give me a star on that. And what about the next thing? So I'm going to do some bug fixes in the future and probably new modules. There are lots of things in mind. But the most important question on this slide is how can you help me? Or how can you help the community? So there are 2 different ways. First of all, if you want to get involved in the development, you are welcome. I would be really happy to see some new faces in there. And please use the next branch from GitHub because that's the bleeding edge version. And yeah, that should be used for development. And I would be really happy to see people doing that. And just come to talk to me, please, if you want to do that. Yeah, just the other one, which is as important as the previous one. If you like the presentation, if you like the tool, please follow me on Twitter and retweet everything related to XFLTReaT because that's how it can access, that's how it can get to other people. That's how it can grow, and more people know about this stuff, the more successful tool can be created from this. So it's, it's a benefit for you as well. So thank you for your attention. Thank you for being here. And I believe we have a few more minutes for questions. So if you have any questions, now is the time, or maybe later, whenever we are having beers or I'm outside. Any questions?
Okay, before we let Balázs go, are there any XFLTReaT questions for him this time? Nope, appears not. Balázs, thank you very much.
Thank you.